Uh, Thanks for being here, everybody. Happy Friday. So today, our guest Jimmy is going to follow up on his previous SQL presentation for Code the Dream. So we've got a link in the chat for the document that he's going to be working out of. So make sure you have that pulled up. And Jimmy, thank you for being here, and take it away.
All right, thank you. Just going to do some intro, let's see. Like Reed said, there's a doc, a Google Doc posted in the chat. If you want to open that up and follow along, it's got kind of the outline of what we're going to talk about, as well as queries that we'll be posting into DB Fiddle if you want to try and follow along. I'm going to go pretty quickly. So I wanted everybody to have this doc for, if you wanted it for later use, just to see what we had, so you didn't have to try and write things down while we're doing this or that kind of thing. So, but just as kind of starting off, I'm gonna do a little intro. My name is Jimmy Fountain. I've been in technology for over 20 years as a contributor for about half the time, and also managing teams, including data engineering teams and data science teams, software engineering, mostly at some startups. I've recently worked at Vettery, which is now hired.com, and a company called Reposit that does travel industry, a B2B service, and previously at Zeal, another startup. So those are where I was in the leadership roles. One thing I found that has been a very helpful tool, as I don't really code that often, I like to do it for fun on my own, but what is a very helpful professional tool has been SQL for me. And I've definitely been continuing to use it day to day for a bunch of different things. So just talking about what we're going to go over here, this is kind of the second part of an intro to SQL. And what I've kind of tried to do here is to give you insights to kind of things you would find in SQL from doing things hands-on that I've found to be really helpful, because you can do like an SQL tutorial and cover some of the stuff we're going to do, like joins and things like that. But I wanted to give you some insight into somebody who's like, I've experienced a lot with data science teams and data engineering teams, and these are kind of the starter things that are going to give you a lot of help. Either when you're writing raw SQL, or you're using an ORM and you want to debug your queries or really understand what's going on under the hood for these. So yeah, and that doc is my email if you want to get in touch, or if you want to connect on LinkedIn, that's also there. The next part of the doc here, there's a couple links. DB Fiddle is where we're going to be working on doing the SQL queries. If you want to follow along, I'll put that on my screen, and so you can follow on my screen if you want. And then there's a couple links to articles, which will make more sense later. One on using Explain for explaining SQL queries or debugging SQL queries, really. And then PT Query Digest, which is a Percona toolkit thing. And I'll talk about those later. I'd say don't need to look at those until we get a little bit later near the end, because that's be more important. So yeah. So why don't I get off start in this kind of outline? I wanted to talk about like a general overview of SQL. You don't need to necessarily have done the intro one, which I did I guess it was a couple months ago, or have basic, too much SQL knowledge. Just a little bit of basic knowledge is helpful. But I wanted to go over like kind of the reasoning here, why you might want to dig into raw SQL and know the debugging over an ORM. ORMs are great if you're working with Rails, or there's ORMs for every language out there. And it's really helpful in application development. But knowing SQL has a lot of uses. So business intelligence is one. As a software engineer in your career, it really helps. People come to you with questions a lot of the times, like how many users signed up in the last week? Or you might want to debug and say, like, it looks like something's wrong with the sign-up process. When's the last time I saw somebody signing up? You can go into your data and look and do a query to do that. A lot of the time that'll go through tools like Tableau or Chartio. And there's actually a lot of companies will have teams that do that. And working with that is a lot of insight into the business. So when you're setting metrics for yourself or your team, when you're managing a team eventually, having SQL and going through your own database, as well as aggregating a lot of data from a lot of sources that you might be using, it's really helpful, because those tools Sometimes they have like tools that are like kind of WYSIWYG things where you can kind of piece things together, but they almost always support SQL. And if you want to do advanced things, usually you'll have to understand SQL a little bit. If you want to go into your career into data science or data engineering, a lot of data scientists that I've worked with do a lot of their modeling in SQL. A lot of it's a combination of Python and SQL, and people use different tools for different things. You know, like MATLAB is popular with data scientists. But data engineering also, having the raw SQL and the ability to work with that directly. ORMs are great, but if you want the absolute, well, if you're doing something that's super complex and a lot of like math in the SQL, that's not what an ORM really does. And it won't do it as efficiently as something that you write yourself and you can debug yourself. A lot of tools use SQL. If you worked with Jira, like if you're managing a team or managing a sprints and things like that, Jira supports SQL to get metrics from the performance of your team or the performance of the sprints and stuff like that. So that's an example of something like a search. You know, it's a SQL-like interface, but a lot of the times it's a thing. And lastly, but not leastly, debugging. Now, even if you're using ORM or something else, this is generating these SQL queries for you. Debugging them, having some knowledge of what's going on under the hood is really important. And that's kind of what I'm going to cover today, and not to like explain and slow query log and indexing and why those are important. So we're going to start here in this queries area. The way this is formatted is there's this SQL comment here, and that's an actual SQL comment. And then here is a little piece of SQL. And so we've got a little bit of setup. Now, if you were to run this exercise on a local database, say you had your own MySQL database, you'll need to create these two things. But when we're using dbfiddle, this is actually done for you. So to start off, what I want you to do is grab these 4 blocks, and I'll talk about a little bit what's going on in there because it's a long piece of text. Go into dbfiddle, I already pasted it in myself, and paste it in this schema area. Now, whoops, as I am saying this myself, if you are set this up, I think it starts off by default as MySQL 5.7. We want to use 8. That's the most recent version. It's going to do indexing a little bit differently. So when we get to kind of understanding what indexing does, we'll do that. I'm not going to go too in depth over these. This is something that I covered. These statements here are creating the tables and then inserting values. Are you all not seeing my screen?
No.
Oh, okay. Well, let's try that again. How's that?
Yeah.
Screen. You should be seeing dbfiddle right now.
Yeah. It's
Great.
really small. Can you make it a little?
I'll do
larger?
this. Let me see if I can make this. And I'll try and expand this a little bit. How's it looking now? A little better?
Yeah, that's better. Thank you.
Yeah. Let me see if I can get rid of this stuff over here. No, they don't allow you to do that here. Anyway, I'll expand this out temporarily so we can take a look at this, and I'll kind of go over this. So, so the way this is this works here, and just to give like an overview of the way dbfiddle works, here's the schema, and this is basically every time you hit this run button up here, it's going to run the schema. So if you're creating tables and inserting data, it's not going to persist overruns if you were to take this out. And then this over here is so that you can write an actual query against this stuff over here. You can put queries on each side, but it's easier to kind of do it like that. So like I said, since you wasn't sharing the screen again before, like what you want to do here is paste these 4 blocks. That's where I got that into dbfiddle. And you can hit run. It's just creating the tables. It's not really going to do anything, but it'll say there's no results. We can do from there, just very basically test. I'm going to do a very basic select statement. And then we'll go a little bit over what's going on here. So voila. So what you see here is just a very basic query where I've gotten just a couple people out of the database. Actually selected all the users here. So let me see. hold on, my DB fiddle is not scrolling. Hold on a sec. Redo this. Okay. Fortunately, DB fiddle UI does not like to be scrunched up this much, so I may have to go back and forth to show you all what's going on. So what I'll do is I'll cover over the create. I'm going to go very briefly over this. I'm going to expand this part out and go over the create. And let me increase the size here a little bit. So what you're doing here is you're creating a table users, and these are the fields here. You've got a primary key and then generally your data fields here. This is an InnoDB table, and then the collation here is a collation that's pretty standard. That's a very large collation for Unicode that'll take a lot of characters. You can use different collations here for performance. I'd say mostly you want to use something like UTF-8MB4, it's a mouthful, Unicode CI. So what that does is, what that means is it's getting a lot of characters, like you have characters with like umlauts and things like that. So Unicode, it's a very broad set. So you won't have a thing, because if you use a very small set, your table might be a teeny bit faster in performance, but you will risk losing data if, for instance, you're using like a U with an umlaut under it. So, and in here, we have the insert of the data. And this is where I'm just inserting some basic example data. And so that's I'm setting up some users and some basic fields. And then here, because we're doing multiple tables, I'm doing an addresses table. And this is going to relate to the users table by this one field here. Now, in this case, what I've done is just called it user_ID. And if you've done things with URMs or SQL, this is a kind of standard naming convention for a foreign key. Now here, even though this is an InnoDB table, a foreign key is not explicitly set, but I'm going to show you that a little bit later. But you can do it this way, where you're just doing this and you're storing an ID from another table to relate it together. So what's happening here, if you see in the data here, and what I'm doing in here is I'm inserting this info here, and you're starting with user ID. The ID here is auto incremented, so there's no field here. But you'll see I'm inserting these numbers here, 1, 4, 5, and 7, and that maps to the users 1, 4, 5, and 7, and I'm associating these addresses with that. Great. So I'm going to go back here, and I'm going to go back to our doc. Shrink this a little so it's not too scrunched up. So here you can select from users, what I just showed you, just so you can see there's something in that table. And from here, I'm going to run something from addresses to make sure I have things in addresses. So addresses, yeah, so it looks like there is. It's a little scrunched up. I'll just expand this out just for a sec. So you should be seeing something like this. So we've got these 4 addresses right now. This is just the, there's not any relationship. But that's where we want to do the magic. So just kind of going back, and I think I skipped over this at the beginning, is the reason that SQL was invented in the first place is like way back in the olden days of computers. We're talking like 1960s and 70s. People were trying to store data and find it basically through documents. You can think of like CSVs. And so a lot of it was scanning the document and trying to find things just through going through it. It's very time consuming and a lot of disk usage for things. So the reason relational databases were kind of invented is to have a sense of where things were, and that's what's tables, but also a sense of where to find things and where to find it quickly, and that was indexes. So what we're doing, the concept we're working at right now is 2 different tables. So you always know where to find this addresses, and link it to the users. So what that does is it saves disk space, because what we'll see later is we can do, let's say like multiple people live at one address, you can do a many-to-many relationship. What we've done here is what's called a one-to-many. So one user can have many addresses based on the data, and that's where that ID in the addresses table goes. So now what I've done here is, I'll go through this statement. So select, and I've selected star, which is every field from this query, from users. And then I've done a left join as in I'm connecting this addresses table, and then you tell it what field you want to connect on. So this is a very standard join. And you can do left joins, right joins. Right joins are interesting that I don't find them that useful. You do need them sometimes. You make a very complex query, but right join is really just flipping the table order. So you're going to do the exact same thing here if you just swap those around. So and so then you're joining on these particular fields. So now I'm using the user's ID, the primary key, and then the user ID, which is mapping to that user ID here in the addresses table. And so here, when we look at the results, it's kind of interesting. So you might think, well, a lot of users here don't have addresses. And I'm like, okay, that's correct. A left join, that's what it does. Basically, a left join says, if a user has an address, show it. If not, show null. And so here you can see there's a lot of people showing with null. And what you might want to use this for is like you're showing a list of people and it doesn't matter if they have an address or not. You still want to show them in a list. And so that's what's happening right here. And you see all the fields, whoops, sorry. And moved my browser around and lost something. But anyway, back to this. So that's what's happening here. Now, what you can do with that is get a little more specific with a left join. And there's a lot of different ways to do these joins. So what I'm doing here is I'm pasting in another query. So this is very similar to that first query. But what I've done is added a where. And so a where says addresses, user ID is not null. Now, I've still got the old results down here, and you can pick any field that you are looking at down here and say, like, is it not null? And that statement, as I run it, should just give me only the people in the user table that have addresses. So you see what's happened here. I've only got these first 4 people. They all have addresses, so that's working correctly. Now, in another way to do this, and SQL on purpose lets it be flexible because, like I said, when you do very complex queries and you're doing lots of joins kind of next to each other, you need these different ways of doing it, left join, inner join, stuff like that. Like, for instance, I'll show you this inner join. And this is different syntax, but the inner join is like, if you've ever like looked at SQL and you'll see a lot of times they'll describe joining by these kind of Venn diagrams. And one of the ways that it's described with an inner join and a left join basically that I just did do the same thing. I'll show you when you run this. So you're going to get the same results. And so, yeah. So that is, but it's a different way to do it. And it's actually slightly shorter syntax. So if you see here, you can basically just do this by this inner join and works basically the same. Now, in my experience writing SQL, I almost always go with left joins because it's, to me, and this is more of a personal preference, you're separating the filtering from the joining. So this is like the filtering and the joining, because it's an inner join, is doing that all in one step. Here, when we had this query, which we saw a minute ago, you're doing where this equals this, or you can say, or you can alter this to say like where user.id equals 1. So therefore, I just get that one row. And then I can, it's more flexible basically, because I could get this one person and their address if they have it, or if they don't have it, I'll still get that one person's basic info. Great. Now this is where things start to get interesting. So we've gotten join, and that's basic joining right there. You can join multiple tables. It'll get more complex later when you get into it. But I wanted to start showing you a little bit about how to understand really what's going on under the hood here with an explain. So what I'm going to do here is, if you take any query that you're working with in your SQL editor, and then you put an explain in front of it, it's going to give you this kind of debugging console. So I'm going to run that, and then we can say, take a look at this. And I'm going to go through what this stuff means. And expand that a little bit and get you to here. So explain is basically what it's doing is telling MySQL or SQL, it'll work in Postgres, I think too, is what this query might be doing. It's estimating some of these things, which I didn't know. I was working with this and I thought they actually ran the query, but what it is estimating, and that will come into in some of the these row counts that we're looking at here. So what it is like you see here, there's 2 rows in the results. There's IDs in there, which I actually don't know why they put those there. It really doesn't seem to have much meaning, but everything else does. So the second thing is tells you what type of query, select type. And I actually posted a link to a really good article that I think explains explain as well, but I'm going to kind of go over where the things I think are the most important here, as well as what these do. So simple means these are straightforward queries. There's things called like subqueries and unions that you will come across. And if those happen, those will be here, just to let you know that it's happening. They tell you what table each of these rows is connected to. There's users here and addresses here. Partitions, you can partition, like if you're familiar with database scaling, sharding in a table. These don't have sharding, so those both have null. Now, this is a good performance one right here. So type here is all. And what type means is like what type of query, like how big the query is. And when it says all, you're doing what's called a full table scan. A full table scan is not great. So what that means is MySQL can't find an index that it can use. So therefore, it's going through the entire table looking for what you're asking for it. So you're doing a full table scan on both of these. And so that's not good. Possible keys, there should be some things in here. It'd be nice if there were, but we haven't set anything yet. And so when these are null, this is also a red flag. That means your tables probably don't have indexes that are usable here. And then here, when it says the key, this is where the indexes that it is actually using are there. And then the key length, this, I don't know if this is that. I don't find that very helpful. It's helpful for very complex indexes. You see how much of the index is being used. I've never really used it for too much. The type, the possible keys, the key are very important. The reference is going to tell you what those indexes are joining on. And then the rows, this is an important one to look at. If you're expecting to get like 20 rows and it's scanning 5,000, it'll show here. And if you get these super high numbers in here, you know you're probably doing something wrong when you only want a certain amount. So this is a good indication when those are really high. Filtered is how much percentage of the results have been filtered. I don't find this super helpful. It's kind of, sometimes it's 100%, sometimes it's 10. It really depends on how much you're getting out of there. But you can see that when you actually do the query. And then here is, it gives you kind of information on what's called the query plan. Your database engine is going to, for the most part, figure out the best way to run your query, what the best indexes are to use and what the best way to do it, and say like using a where and using a join buffer. Those are kind of more, you can find more in-depth information like on the MySQL or Postgres or whatever database documentation. I don't find these to be super helpful. It does kind of give you an idea of what you're doing. But like I was saying, the important stuff is the type, to see how many table or what type of table, if you're doing a full table scan, the possible keys, the key, the amount of rows are really important. So showing that's explain, and then we'll go forward and just going into expanding on this kind of debugging. As we saw from that explain, there's no indexes here. And as I was saying, we didn't set one, but if you wanted to on the command line, when you want to see what the table structure you're working with is like, use this describe command. And then, so I'm doing describe addresses, and that's that table. And so therefore, let me do this again. I'm going to tell you what this looks like. Wow, it's hard to click here. Sorry, there. This shows you the fields in the table and if there's indexes. So the key is the index. So you have a primary key on your ID. We're not able to use that for that class query, obviously, but you can see there's no indexes on anything else. But let's go ahead and change that and make our table much more efficient. So I should actually explain a little bit why I'm kind of going into discovering what's happening with the table. When you have a much larger table, these are very small tables or very small data sets. When you have a much larger table and you're doing these joins and you don't have indexes, performance will degrade very quickly. Like I said, it's doing a full table scan, so it has to read every result in the table to find what you're asking for it for. When you have indexes, it only has to read the index, and the index is much shorter and much more efficient. And I'm just going to talk a little bit about the indexes a teeny bit. So indexes in MySQL are B plus tree. And if you know anything about B trees or indexing or that kind of data structure, these are things that come up on coding interviews often. I don't like them. I find the concepts of learning about these is completely not fun. So I don't give these questions when I interview people, but they do come up, and it's something that if you don't know about, you will definitely see this like on Lead Code all the time. What you don't see very often, but if you are going into data engineering, is the B plus tree. And the difference between the B tree and the B plus tree is you'll see in this diagram, see these arrows between each other. These are pointers to these different leaf nodes, basically. And what that allows SQL to do, and I think this is more important to do, you basically just need to know about this and that. SQL is using this because it is the best kind of indexing that is possible, or they think is possible. There are different ways of indexing, but this is the most common that you're going to see. And it's not necessarily important for you to know this in your day-to-day thing. I think it is important to know it just to kind of know the concept of how that index is working. Going to go to this. So that's kind of a little bit about the kind of mechanics of the index. But the best thing to know, to really kind of keep in mind on that, is that your index is the key to performance. So what I've done here next is this, I'm going to do a alter table statement. So we've already created a table. When you've already created a table, you do the alter table to change it. And so I'm adding a very simple index, and I'm doing alter table addresses. I'm going to add an index, and the name of the index is user_ID index. And then over here, it's user ID. And that's the field I'm going to index. So what I'm going to do here is I'm going to expand this out for a minute, and we're going to look at our whole list of setup. And this is kind of a thing that you do in your setup. A lot of the times this will happen when you've got a table you've made and it's in production and it's not optimal, the performance is not great. You're going to go in and debug, and then you're going to need to add an index. And so this will be part of a migration, usually. Ideally, you'll have this there from the beginning, but things change, and then you'll need to update. So you'll see here, this is a little different than we ran it before. The describe of this table shows user ID with a mul index, which just means multiple. There's unique and pri. There's I can't remember how unique is abbreviated, but primary is abbreviated pri. So we now have an index. So there, if we go back and we do explain, I'm going to go back to this query and run this one again. So we should be able to see that it's actually able to do a little bit of index running. I'm going to expand this again. Okay, great. So this kind of hopefully makes a little more sense now. So you can see here in our type, we have an all on this table, but we also have a ref on this. So it doesn't need to use the index here on the simple. And this is where this kind of SQL query plan comes into play. The reference is saying, I'm referencing another table. They're going to use this user ID index, or this is a possible index that it can use. And then this is the index it's using. And this is the key length of the index. Like I said, not super important. And this is what it's doing. That's our database is called test here, and users ID. And that's the referencing. So addresses is referencing test user ID. It's getting one row. That's great. And it's using where. So you can see it's like this is actually turned into something more simple here. So great. So what we've achieved is a more performant join in our table. So, and then like for debugging this kind of thing is So just arranging some windows a little bit on my side. And for that, let's see, where were we? We were in describe, we did alter table. Great. So great. So we just did the indexing. Now I'm going to go into something a little more complex. So what we've got now, like I was saying, we've got a one-to-many relationship. So if we see in here, we related our users to our addresses. One user can have multiple addresses. Now, what if you wanted to do something like a many-to-many? Now, why would you do that? So many-to-many means that one user can have multiple addresses, one address can have multiple users. So that's if you have multiple people living at the same place. You'd want to do something like that. That's usually what doing that, the best optimal normalized way, which is what you call the best, not the best, but a standard way of organizing data in MySQL is normalization, where you have users in one table and addresses in another table, and then a linking table would be this linking table. And then that's where this comes in. So we have a create table to make a many-to-many relationship here. And so what I'm going to do here is, again, expand on this, make this many-to-many relations. And I'll walk you through this a little bit. Let me zoom it a little bit since we're on full screen right here. So what this is creating a third table that's going to join the two tables. Now I've got a diagram that's going to display what this is going. I'll show you that first. So you see here, let me get this out of the way. Whoa, is this is kind of, this is a SQL DBM tool. There's a lot of tools that will allow you to visually map out table structure. I think they're kind of helpful. The nice thing about these is if you do like these schema docs that we were just working on, it can reverse engineer it for you. So you can either use this or you can bring it in later. So here we have our user table that we made, and it shows the fields. And then you can see here is our addresses table we made previously. And this is the table we're about to make, which is our users' addresses. Now, this has just the primary key, a user ID, and addresses ID. But you see these crow's feet here. What that means is this has a one-to-many to this, and this has a one-to-many to that, therefore making it a many-to-many between the two. So this is kind of a visualization of what we're about to do right here. Users and addresses, and they're no longer linking together. Although in this one, I haven't removed that yet. But when we do that in a minute, you don't need that user's ID here anymore. So I'm going to do shrink this back down. I'm going to shrink this a little down so it's a little more manageable. And there we go. So I just did that. Actually, I have a query that's not really going to show us anything. But what I'll do here is I'm just going to write a very quick query to say like, oh, I'm sorry. Let me explain the fields here while I forgot to do that. Again, like in here, this is a create table. These are similar to what we'd seen before. And there's a user ID and address ID. Now, the important part here is the index creation is in the table create. I would not recommend trying to learn this syntax and then writing it out. There's so many tools that can do this. It's like, it's really no point to try and do this by hand, honestly. But this is how what it works. You're actually creating these two keys, which creating two indexes on these two fields here. This one's already got an index on it because it's a primary key, but then you're doing a constraint. Now, not every table type in MySQL or Postgres will support this, but the constraint is linking this field to another table and another field. And when you do that constraint, let's say you wanted to say something like, when this field is deleted in this table, also cascade that delete to the other rows it relates to. So it's very powerful. Or for instance, same thing with like an update. If you want to update this, then also update another field or something. Honestly, I find that setting those constraints, you can set a constraint here where it's a foreign key where it just links to the table and there's no action on like a delete or something like that. I think that is good. And most ORMs will do that by default. Using the kind of actions, I think, are not so good. I think it's much easier to manage that in your code because you may not want to delete something every time. Because I mean, these are deletes. They're like goodbye, gone, poof, your data's gone. So doing that with like your application code is much more flexible, because what you can do there is soft delete it. Either you hide the record, move it to another database for archiving, et cetera, et cetera. Those are things you can't do with a constraint. Or at least not that I've ever tried to do. Maybe you can run like a stored procedure on SQL, but I don't recommend getting that anytime soon. I speaking of that a little bit, is like, I think it's, if you're working with SQL and you're working with an application layer that's in Python, Ruby, whatever you have, business logic is better stored in that application layer than it is in the database. Only things you really want to do in the database are really like safety of the indexes, like you can add a unique index on a field, but I would very much lean towards keeping your business logic in your application, as opposed to, because you can do like if statements in SQL and stuff like that, but I wouldn't recommend doing it. So we've created that table. We have to do a little more housekeeping to get this working. So I'm gonna have to fill it up with some data. I'm gonna put that in here. And this is very similar to what we're doing. I'm just really, actually, this is kind of an interesting thing. So once you're getting into like advanced SQL on the command line, you can do, it's a lot of flexibility, because like you can see here, I'm inserting just hard-coded values here. But not only can you just insert hard-coded values here, you can grab info from another table and insert it into a table. If you're building a table for some new data. And so this is an example of migration where we've gone from this system where we have a one-to-many, and I'm migrating to a many-to-many, and this migrates. So what's happening here is you're inserting into user addresses, which we just created. You're inserting these two fields that are user ID, addresses ID. So you can see how those map. And then I'm putting a 0 here, as the select has to match the number of fields in that table. And then there's a primary key here. When you put a 0 in there, or you can, I think it's, you can put the keyword default or maybe null even. The ID, because it is auto increment, will just automatically auto increment for you. You can put an actual value in there, but because this is a auto increment field, it may fail and give you something, an error. So we're selecting from users, left join, and basically you saw this query before. So what we're just trying to do is get all this data that we've been storing previously in the other format. So I'm going to run that. It's really not going to do anything. Let me take it to one more thing. Actually, I'll show you what's going on here. So I'm going to take this. Let's go ahead and do a describe. I'm going to go into that table we just made. And by the way, you can see I did this lowercase. If there's any question, you probably already know it's not case sensitive. Almost everybody writes SQL in all caps. If you have a code linter that you're working with, it's going to do that. So great. So what you can see here in this describe of user addresses, now we've created that table and it's got this mul index. So it's got a primary key and then it's got a multi-index. So those worked great. So just letting it know it's there. At the same time, I'm going to just do very quickly. I'm selecting everything from that table to see if we have data in there. I think I put that statement in there. Yeah. So the data went in there that we expected. So I didn't, as you saw, we didn't hard code that data. We're getting that data off of a query. So now, the one other thing I want to do is, because we had a one-to-many here, I'm actually inserting a row manually here that's going to give us a many-to-many relationship. So it's going to add an address, a data condition that will give you user ID 2 is going to share address 1. Now, I've seen from here, my hard-coded ones previously, I've already assigned address 1 to one person. So this is going to assign it to a second person. At the same time, they'll be sharing it. Great. So now we get into the more complex magic. So far, we've been able to create this table, migrate it, and do a bunch of stuff in SQL. And this is where the fun stuff starts. So I mean, it's already been fun. At least I think this is fun. And then here we're actually going to be able to do a query with our new data. So great. So kind of see what's going on here. We've got kind of what looks like we had before, but you see a very important difference. So Hector Newman, who lives at 100 Minetta Lane, apartment 3, and Pamela Jones at 100 Minetta Lane also lives at apartment 3. Those two people are referencing the same address, which would not be possible without the many-to relationship. So this table here has given us that ability. Now, there's a lot of other stuff you can do with the many-to relationship or a joining table specifically. You can do a one-to-many with this table, but you can add fields in here for context. So if these two people live at the same address, you could store a move-in date here. So you wouldn't want to store the move-in date here in your addresses because your addresses only have, you know, one address record for that one place, that one apartment. But you could store that here because there's multiple relationships. And so that's some of the power that you're kind of getting into here in the way you can work with your data. Great. So now what I'm going to do is get into another query where we're going to go back to our explain. So now we'll take a look at see what's going on here. So this is kind of a lot more exciting to look at. It's more fun to look at because there's a lot more stuff going on. So this is like I was saying, the debugging this, we look at this and we say like, okay, and this is a good example. So because of the nature of the query, we basically are just getting everybody and everybody that has an address. So user addresses, although it has indexes, is actually doing a full table scan. And that's okay in this situation because we wanted everybody. But it does say you have possible keys, but MySQL's decided I'm not going to use any of those because you want everything in your query. On the other hand, addresses and users have equal reference. So this is a great equal reference and unique are kind of the best indexes you can use and the fastest. And it's using the primary key, which is a unique index as well. And so I'm sorry, it has possibly can use the primary key for this query, and it also is using the primary key. The key length, like I said, I don't find that super helpful, but here it shows you the reference to it. So in the users table is going to test users addresses, user ID. So great, it's the things we set up, we are working correctly. And then here it's doing that too directly. Now, this is where, you know, these results kind of get confusing to me. Like I said, the extra, it's just null. That's good, it's fine. What you want to, sometimes the things to watch out for, I think, in the extra is if it's using a temp table. So what that means is it can't do the query if there's a subquery or some kind of complex query directly. It has to make a second table to merge your data before it can do what you're asking it for. That's a lot more complex, but it's like nulls are totally fine here, and also using where is fine. When you see a lot of things, like it's doing a lot of operations in the extra, you really have to kind of dig into it and say like, what is really going on there? Okay, so there. Let's see, this is a little bit different, and I'm going to go over this a little bit as just the query here. And actually, yeah, that's one thing. I'm sorry, I forgot. I skipped over doing the multiple joins, and we should go over that. So I'll do this here. This is just another version. I think this is the difference here is, yeah, this was just a left join, and I did where anybody, but then this one I'm specifically asking for a query. Now I'll go over this and like how this is a little different than what we've been seeing. I mean, it's really, it's not super different, but because we have this middle table, you have multiple left joins, and you can keep going with this and have like 50 tables and keep joining them on the left and then join right, whatever. And that's why I'm saying like the different types of joins are helpful. But this is basically pretty straightforward what we're doing. What I've done here is I've changed what we're selecting to specific fields in the users, because if you just did a star here, you're going to get all the fields from user addresses, which is IDs, and it just gets confusing when the results, you really don't need those. This is by far the optimal way of doing things, is specifically specifying what fields you want, performance as well as just working with the data. So first you're starting at the top, you're going left to right, you can go right to left, but users, Then we have go to user addresses, we join that, and then the user is their primary key ID, the user addresses, the user ID, links there. Now, the next line you're joining again. So you're going addresses on user addresses, that table we just joined here, and address ID, and addresses, and then ID. Now in the where, it's fairly simple. I'm just going to addresses and saying like, I just want this one person's address. I'm sorry, or this one address ID, see who's actually connected that. And let's see what we get. And I think I'm going to go back into this view to see this. And, oh, well, yeah, wait and explain, sorry. And expand that back out. So great. So as you saw, since I was selecting it via the ID, I got both people who are connected to that one address ID. So this is what I expected. Great. So I'm going to go back to that. Then I am going to go back to explain again, and we'll just show you what's going on under the hood. So here, well, that's looking a little weird. Hold on a second. Undo that, and maybe, yeah, DB Fiddle really doesn't like being small, but that's the way it goes. Okay, so here you've got a little bit different here. So here we see addresses has got a constant type query. Great one. Not quite as good as unique, but still good. It's looking at the primary key. And then it can use the primary key. And user addresses, it can use user ID and address ID, and then it ends up using address ID. Why it didn't use user ID? It could, but you have to kind of trust MySQL to do this. This is where it gets interesting, because really it's like MySQL over the years has developed a very sophisticated way of like kind of guessing what you're trying to do, and then doing it. And sometimes it will leave out indexes. You're like, why isn't it using that one? There is a way for you to, before you run a query, to say like, use these specific indexes and stuff like that. And when you get into super advanced things, you may actually do that. Rarely, at this point, this has been developed over so many years, it's very rare that I've ever seen anybody use that, except in just to test things out. Usually MySQL is pretty smart, and same with Postgres. They're both very advanced query planners. Oops. And so there, that address ID. And then again, in the users, we're actually also using equal reference, and that's a primary and primary key. So this is what I would consider a very optimal, very well optimized query. So your performance is going to be great. So great. That's kind of what the most of the kind of the joining and the querying and stuff like that I wanted to go to. I'm going to go to a couple other things as far as performance in SQL is concerned. One is something called the slow query log. Now, this is a great debugging tool. And if you see in this doc here, down at the bottom, I've got, this is not a query you will run, but it's an example of what you see in a slow query log. So you enable the slow query log either locally on whatever database you're working on, your production database. And what it does is any query over a certain time limit, usually 1 or 2 seconds, will show up in this log, and it'll give you this data about it. And this is great because things that's happening when you're not watching the app, or certain conditions may happen, and you'll get these logs, you'll get these queries in there. You'll get these log entries with the queries that they're pertinent to it. So I just put this select star from users. This is not a real thing, but just to show you what's going on. Now, this is a very, it's very raw log format. You know, I can go over these, like the most important thing you're going to look at is query time. So this is 11 seconds. If this query took 11 seconds, something's up. You know, queries are, you would often see queries looking at like this in SQL, and that's what you want to do. The lock time is also something to look at. If you have operations that cause a database lock, like a write lock, that means no other table can use it. That's bad. Rows sent, if you're sending way more rows, similar to what the explain I showed you before, if you're sending more rows than you thought, like say you had 100 users, but you're sending 10,000 rows, something's wrong. And you might want to look at that query. This query is very simple, so you probably wouldn't have that problem here. Same with like rows examined. That can be super, super high because you're joining on a lot of different things and your filtering is not specific enough, like your where. And then rows affected, this is if there's an update, it'll show what happened. And then this is a byte sent. As like how big the results are, which is actually something valuable because sometimes what will happen is a query will go awry, your data will get really, really big and your app will crash because it's sending too much data out of the database into your app. So if this is like 5 megabytes, you're like, wait a minute, why am I getting 5 megabytes of results when I expect to get like 20 users? Like for instance, you do if that was something like this, this would be a big red flag. So if you limited this to 10, then, you know, that's like crazy. Why are we sending like a bazillion bytes? 57 bytes is not much though. So this is very helpful if you are having problems in production or you want to have some insight, because like locally you can really see as you're developing, these kind of go in real time. It's not that important, but it is important when you have a lot of users and a lot of things. A lot of tools can do this for you and they'll aggregate it. And one is like New Relic, and they will go and kind of aggregate that. Another way you can do that, and I'll introduce you to this company, Percona, and let me zoom them in. Percona is a database tooling kit, and they're a company that does consulting. And this one tool, I just linked it in the doc, is something called PT Query Digest. And it analyzes your logs and your slow logs from MySQL and gives you so much more insight because it does aggregation. Because like, let's say you've got a slow query, it might be running hundreds and hundreds of times a day. But this will show you, it's a lot of options. So, you know, I would say you can spend, this is a very long talk too. You spend a long time, but it's so powerful. You can look at your database performance in so many different ways. One option that you have that I think is great with a slow query log is if you hit a slow query, you can filter, you can activate the slow query log by slow query, unindexed queries, if queries are not using any indexes, and you can add the explain when you do that. So much data you can get from this. But if you're getting into database administration, working with data, MySQL, Postgres, they actually have tools that are for Memcache and things like that, other databases. But this toolkit is super, super valuable tool. And I think it's super great. So that's a brief overview of what the slow query log can do. I think that if I'm looking at the outline is about it. Yeah, slow query log. And so that's kind of getting to the end here. So I can stick around and field questions on anything if people want to do that. I'm going to stop sharing my screen. Or go over things if you want. Yeah, and otherwise that's it. And you have this doc and you have those links. I'd say like, check out Percona Toolkit, check out that article on Explain, and then happy SQLing. So any questions or anything? Great. Cool.
Thank you.